Good morning, Earth Science students. Welcome to video lecture episode 5. Episode 5. We're going to today finish up section 1 of chapter 15. Remember, chapter 15 is dealing with the atmosphere itself. So let's go ahead and look at slide 60 to finish up our discussion on the ozone layer. Remember, the ozone layer is protection for us from ultraviolet radiation. In other words, it protects us. Now, if that ozone layer is affected, remember UV radiation, that referring to ultraviolet radiation, can cause sunburn, skin cancer, eye cataracts, and skin aging. Now, if you look at that same image on slide 60, you'll notice that it has ultraviolet, visible, and infrared. Those are just a small portion of what's called the electromagnetic spectrum, and you can see where ultraviolet radiation has its place. Let's move to slide 61. So we're going to talk about CFCs and their connection with the ozone. Evidence exists that some air pollutants are actually destroying the ozone layer, and that means they're literally taking out that protective layer we have. So what is the CFC? Well, a CFC simply stands for chlorofluorocarbons. That's the molecule. And if you notice on slide 62, I have a small image of that molecule. And you'll see another image of that on slide 63 if you want to skip ahead just to see that quickly. So blame has fallen on these CFCs, these chemical compounds used in some refrigerators, air conditioners, and aerosol sprays, and in the production of some foam packaging. These CFCs can enter the atmosphere, and if these appliances leak, or if they and other products containing CFCs are improperly discarded, they can also be introduced into the environment as well. Now let's move to slide 63. Now recall, folks, just remember what we talked about. Ozone molecules are made up of three oxygen atoms bonded together. The CFCs, which, as you can see in the image there on slide 63, they actually destroy ozone. And let's talk about how that actually occurs. So in slide 64, we talk about how that occurs. So when a chlorine atom from the CFC molecule comes near a molecule of ozone, the ozone breaks apart, which, as you can imagine, that's not a good thing. Looking at slide 65, we can just visualize how that actually occurs so you can kind of see that. Now, one of the oxygen atoms combines with the chlorine atom, and the rest form a regular two-atom molecule. So what happens is that ozone breaks up, and two of the oxygens remain together. They're diatomic, that meaning two of the same element, and then the one has combined with the chlorine. Now these compounds that have been created as a result of this don't absorb ultraviolet radiation the way ozone can. In other words, we're not protected the same way. Now, in addition, the original chlorine atom itself can actually continue to break apart thousands of ozone molecules. Did you hear that? Thousands of ozone molecules. That's a lot of molecules for just one chlorine atom. Now, the result is that more ultraviolet radiation reaches the Earth's surface, which means obviously those conditions connected are going to increase based on more UV radiation being able to reach the Earth. Let's go ahead and finish up this section with a health integration. Moving on to slides 68 and 69 and following, each year more than 1.3 million Americans develop skin cancer. Take that in, just let that sink in a little bit. And more than 9,500 die from it. Now, exposure to ultraviolet radiation can cause skin cancer. And looking at the images below on slide 68, I know it's a bit disturbing, that one in the middle, but this is just the reality of what can happen. On slide 69, I have one of those images zoomed in a little bit better so you can see it, and it just shows at least 6 different types of skin cancer. Now let's go ahead and let's wrap things up and talk about some means, or at least some things that have happened as a result of this. Now, if the ozone layer disappeared, obviously, as mentioned already, skin cancer rates will increase, and how much could vary, but it's certain they could increase. Now, in 1986, I was about 4 years old, scientists found areas in the stratosphere with extremely low amounts of ozone. And in connection with that, they found one large hole that was found over Antarctica, and a smaller hole was found over the North Pole. Now, what we can see, and you can look up images on this, we can show how the ozone layer is actually thinned and developed holes as a result of this poor management. Now, thankfully, in the mid-1990s, many governments banned the production and the use of CFCs. What they're hoping is that over time, the areas where the ozone layer is thinning will recover, because this is not being introduced destroying the ozone, and the ozone will have time to recover. We'll just have to wait and see. If you have any questions, please leave them in the comments below. And if there's anything else I can help with, please reach out to me. Have a nice day, and I hope this helps.